Hello everyone, I'm Hans. In this demonstration, I will walk through a simulated interaction between a caregiver and a chatbot designed according to the principle outlined in the paper. Critical conversations are a user-centric approach to chatbots for history taking in the pediatric intensive care unit. Due to the time constraints, the demo is intentionally concise. However, it reflects a viable and deployable workflow suitable for the future research and clinical evaluation. I will assume the role of a caregiver responding to 5 core history-taking questions posed by the chatbot, followed by a summary for confirmation. Let's begin.
Hello, I'm Tracy. I'm here to help the care team understand your child's situation as clearly as possible. I know this can be overwhelming, and your answers will help us take better care of your child. Please take your time. If anything is unclear or feels uncomfortable, you can skip it. To begin, could you please confirm a few basic details about your child? What is your child's name, age, and gender?
His name is Leo, 2 years old, and he's a boy.
Thank you. In your own words, what brought your child to the hospital today?
He had a high fever and started breathing very fast.
When did you first notice these symptoms, and how have they changed over time?
The fever started yesterday afternoon, and his breathing got worse overnight.
Has your child had any significant medical problems in the past? Is your child taking any medications, or does your child have any known allergies?
No medical problems, no medications, and no allergies.
Have there been any recent exposures, such as sick contacts, travel, or changes at home? And are there any challenges at home? For example, transportation, getting medications, or caring for other children. That might make the situation harder right now.
His sister had a cold last week, and transportation can be sort of difficult at night.
Thank you for answering these questions. Here's a summary of what you shared. Leo is a 2-year-old boy. He was brought to the hospital because he developed a high fever starting yesterday afternoon, and his breathing became very fast, worsening overnight. He has no significant past medical problems, takes no medications, and has no known allergies. His sister had a cold last week. You mentioned that transportation can be difficult at night. Please review it and let me know if anything needs to be corrected or added. Does this summary look accurate, or would you like to make any changes before it's shared with the medical team?
I think that's accurate.
Thank you. I will share this with the medical team.
Okay, we will stop the demo here. In practice, the chatbot can flexibly expand to the conversation to include 10 to 20 questions, depending on the depth of the information needed and the willingness and the capacity of the caregiver or patient to engage. This adaptability allows the system to balance information completeness with caregiver burden. Now we briefly go through the architecture under the hood. At the beginning, the caregiver interacts with the system using natural speech. Their voice input is first processed by assembly AI, speech to text, aka STT, which converts speech into text in real time. And then the transcribed text is sent to the core engine Gemini 1.5 Flash LLM, guided by a structured safety constraint prompt. The LLM asks history questions, maintains an empathetic tone, a voice diagnosis, and generates a natural summary for confirmation. During the conversation, relevant context and caregiver-confirmed information are stored in the master database, allowing continuity while maintaining privacy and section isolation. The LLM text responses are converted to speech using Cartesian text-to-speech, aka TTS, and delivered through Tower's virtual avatar, creating a more natural and human-centered interaction. All components are orchestrated within the LiveKey framework, which is also used by OpenAI, enabling low latency, real-time audio and interaction. Overall, the architecture is designed to be low latency, low cost, and high safety, making it well suited for research prototypes and future clinical evaluation. High safety also means the system can be deployed locally, which is is crucial in medical settings where data privacy and security are paramount. In addition, the architecture can extend it to support clinician-facing functionalities such as symptom analysis and treatment consideration by incorporating RAG or control web search. These components can be designed with hallucination mitigation strategies, ensuring that any clinical information remains grounded, transparent, and supportive. Okay, that's pretty much I demonstrated today. Thank you. Bye.